Antarctica and its mysterious strong gravitational field that baffles scientists. Antarctica covers the southern tip of our planet as one of the largest land formations in the world. We can look at the image of Antarctica on Google Earth and we'll largely see an unpromising white mass, but beneath a seemingly impenetrable sheet of ice lies endless hidden mysteries to tempt our curious minds. For example, there's still no explanation for the widely publicized Wilkes ground anomaly. It's a huge crater with a gravitational force at the center so great that it creates a bubble strong enough to be detected out in space. Scientists say this anomaly is what remains of an asteroid that hit Earth millions of years ago, but not everyone is convinced that an ordinary asteroid would produce such a strong gravitational field. And according to Wikipedia, the Wilkes Land anomaly, the giant impact crater beneath the Wilkes Land ice sheet, first proposed by Richard A. Schmidt in 1962 on the basis of seismic and gravity discovery of the feature made by the U.S. Victoria Land Traverse in 1959-60, the data provided by Schmidt. He further considered the possibility it might be the elusive source of the tektites of the Australasian strewn field, which is about 800,000 years old. The hypothesis, detailed in a paper by Whitehaupt in 1976, evidence cited including a large negative gravity anomaly coinciding with the subglacial topographic depression, about 151 miles across, having a minimum depth of 2,782 feet. Now, gravity anomaly is a location on the Earth's surface. Is the difference between the observed value of gravity and the value predicted by theoretical model. If the Earth were an ideal oblate spheroid of uniform density, then the gravity measured at every point on the surface would be even. Now, the mass concentration. The Wilkes landmass concentration, or MassCon, is centered 70 degrees south, 120 degrees east, first reported at a conference in May 2006, the team of researchers led by Ron von Friess. Now, due to the site's location beneath the Antarctic ice sheet, there are no direct samples to test for evidence of impact. Just like we had, for example, 66 years ago in the Yucatan Peninsula with the Chicxulub crater, there are here in Antarctica alternative explanations for the mass concentration, such as formation by mantle plume or other large volcanic activity. Now, we know that we already have over 140 volcanoes under Antarctica, a lot of them supposedly the size of Yellowstone. So it could be that this is a mantle plume. There are alternative explanations for the mass concentration, such as formation of mantle plume or other large-scale volcanic activity. If this feature really is an impact crater, then based on the size of the ring structure, it has been suggested by Fries's team that the impactor could have been 4 or 5 times as big as the Chicxulub impactor that caused the dinosaur extinction event. Now, because mass concentrations on Earth are expected to dissipate over time, Fries and his collaborators believe the structure must be less than 500 million years old, and also note that it appears to have been disturbed by the Rift Valley that formed 100 million years ago during the separation of Australia from Gondwana. So that only happened 100 million years ago. The researchers therefore speculate that the putative impact and associated crater may have contributed to the separation by weakening Earth's crust at this location. So the impact could have caused the separation of the Gondwana supercontinent. These bracketed dates also make it possible that the site could be associated with Permian-Triassic extinction level events. The Permian-Triassic occurred about 250 million years ago. It's believed to be the largest extinction event since the origin of the complex multicellular life. Plate reconstructions for Permian-Triassic boundary place the putative crater directly antipodal to the Siberian traps. The Siberian traps, you know, are in the near the Arctic, the Siberia area of Russia, and that was the massive eruptive events that formed the traps in one of the largest known volcanic events in the last 500 million years, and those eruptions were going on for tens of thousands of years. So the Fries and his colleagues in 2009 used a controversial theory that impacts can trigger massive volcanism at their antipodes. In other words, let's say something impacted, it's I guess when you put pressure on a balloon, something impacts the south, you're going to have volcanic eruptions in the north. Okay, antipodi, the other side of the other side of the foot. Now, to bolster their impact crater theory, but there are already other suggestions, candidates for giant impacts at the Permian-Triassic boundary, such as Bedout, off the north coast of Western Australia, although all are equally contentious, and it's currently under debate whether or not an impact played any role in this extinction. The complete absence of a well-defined impact ejecta layer associated with Permian-Triassic boundary at its outcrops within Victoria Land and the central trans-Antarctic mountains argues against there having been any impact capable of creating a crater the size of the hypothesis Wilkes Land impact crater within Antarctica at the Permian-Triassic boundary. Nonetheless, according to Fries, recent studies in 2018 seem to sustain the impact origin of the crater, and the event may be linked to separation of eastern Antarctica from southern Australia. This is according to Wikipedia. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.